Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss shift register only up to 4 bits. Let's begin. When we are dealing with addition, we use adder as arithmetic circuit. For subtraction, we use subtractor as arithmetic circuit, but when we perform multiplication and division, it's so tedious to add a number of adders or number of subtractors. Therefore, a new kind of arithmetic circuit we have to introduce, that is shift register. Shift register, a group of flip-flops in a register capable of shifting binary information or data to places either left or right, is called shift register. Register, that is the combination of binary cells or memory cells in which binary data are stored. A number of flip-flops in that particular of register is used to shifting binary information or data. Take an example. When we entry, let a number 1 to 5 into that of calculator. First we entry 1, so in calculator it is so 1. Then we write 2, then 1 is shifted left to a position. Again 5, so 1 and 2 again shifted. So finally at output of that of screen of calculator we show 1 to 5. In this way, if we add addition, subtraction, any kind of algebraic operation, so that 1 to 5 again shifted to off position. In this way shifting takes place. So that shifting can be executed by using shift register. So what is the function of these shift registers and how these circuits are organized? Let me discuss one by one. First, various kinds of flip-flops we use in that of register. For what prospects we use flip-flops? For synchronous transfer operation of data, we use flip-flops in these registers. So what is synchronous transfer of data? In this process of data shifting, data bits are transferred from one flip-flop to another flip-flop, and it takes place an application of a clock pulse signal. Here we taken JK flip-flops. JK flip-flops, when we are dealing with SR flip-flop, there will be a condition when two inputs are 1 1, so the output is 1. This is the invalid situation in SR flip-flops. To avoid that invalid situation, to validate, we use a new kind of flip-flop, that is JK flip-flop. In that of JK flip-flop, a clock pulse is introduced in order to trigger that particular flip-flop. So here the data is transferred from flip-flop A to flip-flop B. It is flip-flop A to flip-flop B are the falling edge of that of clock pulse. As a result, which data in flip-flop A is lost, and the output of flip-flop B will be same as that of flip-flop A, and this type of data transfer is called synchronous transfer, because it occurs due to the output in a clock pulse. due to introduce the clock pulse, the data is transferred synchronizing way. Therefore, JK flip flops are used in these registers in order to shifting purpose. This is shift register that synchronous data transfer operates by using flip flops. This is the synchronous transfer of data. Now, methods of shifting the data. The data bits in a shift register can be shifted in two different ways. One is serial shifting and another one is parallel shifting. What is serial shifting? In serial shifting method, one bit data is shifted at a time for each clock pulse in serial manner, and that shifting may take place from most significant bit end or from the least significant bit end and leave at other end. As we taken up to 4 bit, that is the most significant bit end, let that one with the least significant bit end, that is the serial data input. Here we obtain serial data output. So, data is transferred serially, either most significant bit to least significant bit or least significant bit to most significant bit, but the manner of data shifting is serially. In that of 1 bit, here 1 bit, here also 1 bit, 1 bit, 4 bit data transfer. The method of shifting is a serial shifting. Next, another method, that is parallel shifting. In parallel shifting method, all bits of data are shifted at a time for a single clock pulse in parallel manner. The data are made to enter or leave involving all the bits simultaneously. Taking 4 bit data input, data output, most significant bit, that one least significant bit. So, at that of section we have parallel data output, that section stand for parallel data input. So, shifting of data is categorized into two. One is serial shifting, another one is parallel shifting. Here data shift in serial manner, here data shift in parallel manner by the application of clock pulse. That clock pulse is introduced when we are dealing with flip flops. Next, so depending upon that mode of shifting of data into or out of that of shift register, there are 4 types of shift registers. Shifting data is in, data is out, data is in, data is out. On that basis, we classify the shift registers into 4 categories. First category, serial in, serial out, SISO. Serial in, parallel out, parallel in, serial out, and parallel in, parallel out. 4 different kinds of shift register. On the basis of mode of shifting, we classify serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out shift register. Let us discuss all these shift registers one by one. And here we taken these shift registers only up to 4 bits. First one, serial in, serial out shift register. Serial in, serial out. In serial out shift register that consists of 4 number of JK flip flops, flip flop A, flip flop B, flip flop C and flip flop D. Here data is inputted to that of J and its complement towards K by taking a NOT gate, and the output of QA towards J and output of its complement towards K. Similarly, pattern it is followed and a clock pulse is applied to that of flip flop B, flip flop C and flip flop D. So, how that operation holds? The data to be shifted in place of the input terminals of that of JK flip flop. Look here, to shift 0 into the flip flop, we have the condition J is equal to 0 and K is equal to 1 to shift 0. Again to shift 1, into the flip flop J is equal to 1 and K is equal to 0. So, here we taken the master slave of JK flip flop whose logic level sense at the falling edge of that of clock pulse. Initially, all the flip flops have the inputs J is equal to 0 and K is equal to 1 except that first flip flop. The flip flop A is given as J is equal to 1 and K is equal to 0 at the beginning, and all the operations can be understood in that of graph. Let me see that graph. Here clock pulse is applied. So, at that of QA end, at QA end we obtain that output. Again that is transferred to QB end, and again this is transferred to QC, and finally it is towards QD. So, at QB end, here QA also there. So, in graph it is seen to us. This is QB. Next for QC. QC. Next for QD. that is for Q D. Due to the application of that of clock pulse at output, we obtain that can be easily understood by taking the data transfer table. Clock pulse input output, clock pulse applied input DI, output QA QB QC QD. When no pulse is applied, there will be no pulse at initial condition, that is the input section is the initial condition, or we can say that will be no data. So at output we have 0. When pulse is applied, first pulse is applied, so our input section D0, so D0 at output at QA all are 0. Again another pulse is applied, so here input D1, so at output that D0 will be there, that is shifted to one position, then D1 all are 0. Next pulse is applied, input D2, again that D0 is shifted to this, D1 to that, at that of section we have D2, there will be 0. Another pulse is applied, input section D3 shifted D0, D1, D2, D3. Again we apply a pulse, so at input no input, but the shifting continues as 0, D3, D2, D1. Another pulse is applied, input 0, shifting continues as 0, 0, D3, D2. Again another, let we introduce a pulse, input 0, shifting as 0, 0, 0, D3, here D0, that is the least significant bit, here D3 is the most significant bit. In that way at output we obtain that 4-bit binary number. This is first kind of shift register, that is serial in, serial out, serial in and serial out. It's operation and data transfer. Clarify what will be the operations in that kind of shift register. Next, serial in, parallel out, serial in, parallel out shift register. The 4 flip flops, flip flop A, flip flop B, flip flop C and flip flop D are wired to give 4-bit parallel 4-bit register. They are interconnected in such a manner that the output of flip flop A is transferred to flip flop B and the output of flip flop B is transferred to flip flop C, and again the output of flip flop C is transferred to that of flip flop D, and the data bits are fed to the register 1 after another as the inputs of flip flop A. Finally, the data value can be read directly from the 4 outputs QA, QB, QC, QD as 4-bit parallel data output. So that operation we can easily understood. Here is the data input, the clock pulse. Here we taken the master slave JK flip flop whose logic levels change at the falling edge of that clock pulse. Initially all the 4 flip flops are reset, right. Initially all the 4 flip flops are reset condition. Therefore all the outputs initial condition at QA to QB we obtain 0 0 0. By application of clock pulse the output we obtain at QA next another pulse is applied, so at output we obtain at QB next pulse is applied, that is at QC next pulse is applied at QC. So in data transfer we can easily show it when no pulse is applied, no clock pulse, it is the initial condition, no data. As we say all the flip flops are at reset condition, all are at 0 QA up to QD. When first pulse is applied data input at D0, so at QA we obtain D0, all are 0 here obtain. Next pulse is applied input D1, the shifting like D1 D0 all next to QC and QD are 0. Next pulse is applied input D2, here D2 D1 D0, it is the shifting. Another pulse D3, here D3 D2 D1 D0, your D3 is the most significant bit, D0 is the least significant bit. So at output we read it that 4 bit data by taking serial in, parallel out, shift register in the circuit operation. Next data transfer. Next kind parallel in, serial out, shift register, parallel in, serial out, shift register, the circuit symbol. For JK flip flops, here clock pulse is applied to all these 3. Again we have an input towards K line, but due to clarity for that of picture we don't write these inputs to that of K lines. Let me understand it. In order to show that 6 number of AND gates and 3 OR gates are used, that line is the shift or load line, or which is known as the control line. This is the control line, and a NOT gate is used if the shift load is 1, then another section is 0. If that is 0, another one is 1. So D0, least significant bit, is introduced to JA, and control is given to that control line. In that way, here control line to AND gate, D1 is input, another line to that of 2 OR gate, that is JB. Next at QB, that is the input to that 3, D3, D2, D3. Output serial data output we obtain. So what is the operation? Shift load line is the control line. The shifting and loading takes place in the system according to the logic level assigned to that of control line. That is the important point. When the logic level is 0, loading of data takes place, and when logic level is 1, shifting of data takes place. So that control line decide either load or shift. If it is 0, then loading. If it is 1, it is shifting. How? Let me understand it. That system has 6 number of AND gates. Number as 1, 2, 3, 4, 5, 6. When the logic level of control line is 0, control line is 0, the output of OR means 1, 3 and 5 number AND gates all are 0, and the outputs means QA, QB, QC and QD of the flip flops cannot be transferred to the input terminals of the next flip flop. Next, the other lower signal gets 1. Since it is 0, other lower signal will be 1 due to the presence of NOT gate. So the outputs of even numbered means 2, 4, 6 AND gates will be value of data assigned to that of corresponding flip flop. Eventually, the data we have D0, D1, D2, D3 is loaded to the inputs of that of 4 flip flops at the same time. This is the parallel loading occurs. When the logic level is 0, the loading takes place. As you say, logic level is 0, 1, 3, 5 and not transferred to this QA, QB, QC, QD, and finally we obtain D0, D1, D2, D3. Similarly, when logic level is 1, this line is 1. So the outputs of 2, 4, 6 AND gates will be 0, and finally we have the outputs D0, D1, D2, D3 at the shifting condition. So the logic level is 1, shifting of data takes place. In this way, the operation holds in parallel in serial out shift register. So transformation of data, that is shift or load, clock pulse, input, 4 outputs, no shift load is given, no pulse is given, that be the initial condition, at output all are 0. But when the control is shift load control is 0 and pulse is given to this, so the initial condition D0, D1, D2, D3, all are loaded. Level is 0, all are loaded. So the output we have D0, D1, D2, D3. Here the D3, that is the output. This is the output most significant bit. Output most significant bit. Next, if the shift load control line is 1, we assign the logic symbol 1. Pulse is applied, clock pulse. Initial input 0, all are missing. So the output here we obtain 0, and it will be shifted to D0, D1, and output as D2, D2 at output. Similarly, at 1, shifting takes place, taking the clock pulse, shifting towards 0, 0, D0, D1, and output. Next, control line 1, clock pulse is applied, 0, shifted to 0, 0, 0, D0, and output, which one is least significant bit. So we obtain at output by taking that parallel in, serial out, shift register operation, and data transfer in parallel in, serial out, shift register. Next kind of shift register, parallel in, parallel out, shift register. The 4-bit parallel in, parallel out shift register consists of 4 JK flip-flops, and these 4 JK flip-flops are not interconnected to each other. But in previous cases, all are interconnected with each other, but in that of case, each JK flip-flops are not interconnected with each other, because no serial shifting of data is required. Only the shifting is parallel to parallel, parallel in and parallel out. Therefore, no interconnection is required in between these JK flip-flops. That is the simplest configuration among all the 4 configurations, as we have already discussed the 3 configurations. Here they are the parallel inputs and parallel outputs and the consequencing clock pulse signal. Consequencing clock pulse signal. In that of figure, the connection to K terminal are not shown for the clarity of the drawing, but they act as usual. We determined it. Now, how the operations holds in that kind of shift register? The first flip-flop stores D0, that appearing to JA. Similarly, D1 to JB, D2 to JC, and D3 most significant bit to JD. And all this data are loaded at the instant of first clock pulse when applied. At the same time, the bit stored in each individual flip-flop also appears in their respective output pins, means that QA, QB, QC and QD, we have D0, D1, D2 and D3 respectively. D0, D1, D2 and D3 respectively we obtain at these output sections. The data transfer we clearly understood. No clock pulse when we applied, that is the initial condition. All are 0, but when clock pulse is applied, So at input D0, D1, D2, D3. So at output D0, D1, D2 and D3, where D0 that is the output of least significant bit and D3 that is the output of most significant bit. These are the outputs we obtain at D0, D1, D2 and D3 in case of parallel in and parallel out shift register. In this way, with the help of this video lecture, we understand the concept of shift register only up to 4 bits. What is shift register? Its function by using synchronous transfer operation of flip-flops. What is synchronous transfer? Method of shifting, it is two kind, one is serial shifting, another one is parallel shifting. It is serial shifting, this one is the parallel shifting. On that basis of mode of shifting of data into or out of that of shift register, we classify it into 4 categories: serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out. First, serial in, serial out, its circuit, operation and data transfer. Next, serial in, parallel out, its circuit, operation, data transfer. Next, parallel in, serial out, its circuit, operation based upon the control line, its data transfer. And finally, parallel in, parallel out, one of the simplest circuit of shift register. This is the circuit, its operation and data transfer. So, with this useful and informative notes, let me wind up this session. Thank you.